So for item number 1, we are asked to find the voltage in Vg and the power inside 20 ohm resistor power. So let's start. May I erase this first? So the first thing we should do is to simplify the circuit so that we can solve these values more easily. And we can do that by noticing that these two resistors, the 20 ohm resistor and 5 ohms resistor, are in parallel. So we can combine them with 1 over R is equal to 1 over 20 plus 1 over 5. And that will give us R is equal to 4. Next, we notice that these two resistors are in series, and we can combine them. That will give us R is equal to 12 plus 6 equal to 18. Then we redraw this circuit with these new values R equals 4 and R equals 18. So what we need to do first is to find the current inside the 9 ohm resistor. And we can solve this because we know that these two connections are in parallel. And that means the voltage in the 9 ohm resistor equal to the voltage in the 18 ohm resistor. Like these two. And the known I9 times 9 ohms equal to 1 ampere times 18 ohms. And that will give us I is equal to 2 amperes. Then since these two resistors are in parallel, we can combine them. And that would be 1 over R equal to 1 over 9 plus 1 over 18. And that would give us R is equal to 6. Now, after redrawing this, the circuit will look something like this. 6 ohms. But we don't know the current that flows through the 6 ohm resistor yet. And before we combine this, these two resistors have different currents flowing into them. So we can find the current in the 6 ohm resistor by just adding the individual currents of 9 ohms and the 18 ohms. And that would be I in the 6 ohm resistor. 6 is equal to 2 plus 1, which is 3. And then we just redraw this circuit with R equals 6 and I equals 3. So next, the circuit is starting to look more simple. And the next thing we notice is that these two resistors are in series. And we can just combine them by adding their individual values. It would be R equals 2 plus 6 plus 8. We do not know the current inside 24 ohm resistor. And since these two resistors are in parallel, and that means the voltage in the 24 ohm resistor just equal to the voltage in the 8 ohm resistor. And then since V equals IR, and then I in the 24 ohm resistor times 24 ohms is equal to 3 amperes times 8 ohms. And that would give us I in the 24 ohm resistor is equal to 1. I is equal to 1 here. Next, we should combine these two resistors in parallel. And that would be 1 over R equal to 1 over 24 plus 1 over 8. And that would be R equal to 6. So to find the current in the 6 ohm resistor, that is after combining these two, you just need to add the individual currents to the resistors. That would be I in the 6 ohm resistor is just 1 plus 3, 4. Next, we redraw the circuit with these values R equals 6 and I equals 4. So the next thing we see is that the new 6 ohm resistor and the 3 ohm resistor are in series. So we combine them. R is equal to 6 plus 3 plus 9. So we don't know the current inside 72 ohm resistor. And since these two connections are in parallel, and that means voltage in the 72 ohm resistor is equal to the voltage in the 9 ohm resistor. And that would be I in the 72 ohm resistor times 72 ohms is equal to 4 amperes times 9 ohms. And that would give us I in the 72 ohm resistor equal to 0.5. We just write down 0.5. And then since these two resistors are in parallel, we can combine them with the equation 1 over R is equal to 1 over 72 plus 1 over 9. And that will give us R is equal to, we just calculate that, 1 over 72 plus 1 over 9, and that would be 8. And to find the current inside this 8 ohm resistor, we just need to add the current in the 72 ohm resistor and the current in the 9 ohm resistor. And that would be I in R8. Oops. How did I write that down? I in 8 ohm is just 0.5 plus 4. And that would give us 4.5. Then we just need to redraw the circuit again and with these values. Next thing we do is to combine these two resistors in series. And that's just the sum of their individual values. R equals 4 plus 8 equal to 12. We do not know the current inside the 108 ohm resistor. And since these two connections are in parallel, we can just show that V108 is equal to V 12 ohms. So I in 108 times 108 ohms equal to 4.5 times 12. And that would give us an I of 4.5 times 12 over 0.5. Since these two resistors are in parallel, you can just combine them with 1 over R equal to 1 over 108 plus 1 over 12. And that would give us in our value of 10.8. So to find the current flowing in the 10.8 resistor, you just need to add the currents before they were combined to one to 10.8. That is I equals 0.5 and 4.5. So the current that would flow in this resistor would be 0.5 plus 4.5 equals 5. So now we have simplified the circuit to its most basic component, and since this is just in series, the equivalent resistor value is just 1.2 plus 10.8 equal to 12. And since the current is just, we already solved the current here, 5, 8, we just plugged in those values. Vg equal to 5 times 12 equal to 60. And there we have it. Vg equal to 60 volts. But we still need to find the power dissipated in the 20 ohm resistor from before. This one. We just erase this stuff. We're still asked to find the power dissipated here. So let's go back to a more recent drawing here. We already found out that the current flowing in the 8 ohm resistor is 4.5. And since these are in series with the 4 ohm resistor, then the current flowing in the 4 ohm resistor must also be 4.5 amperes. So let's split back 4 ohm resistor to its original components, 20 ohms and 5 ohms. So how did we find out that V is equal to 18 volts? Well, that is just from before, 4.5 amperes. We have already I equals 4.5 amperes and R is equal to 4 ohms. And V is equal to 4.5 times 4. And that will give us 18. Since this is a, oops, since this is a parallel connection, that means the source voltage, 18 volts, is just equal to the voltage of points. So the voltage in the 5 ohm resistor is still also 18. And in the 20 ohm resistor, also 18. Now we have the values needed to solve for the power in the 20 ohm resistor. And that's just power equal to V squared over R. And that will be V squared over 20. And that will give us that power is just 16.2 watts.